Today's session is about the new chapter called probability. What do we mean by probability? Before we get into understanding probability, imagine I take a coin. We all know that we have seen in many cricket matches where before we just decide on the batting and the fielding decision, the captains are made to toss the coin. And then based on the outcome of head or tail, then either of the captain decides on batting or fielding. What do you think is the relation between tossing of a coin and the cricket match, or deciding between the batting and the fielding? There's very mathematical, deep history behind tossing of a coin and deciding the batting or the fielding in the cricket match. So let's see how they are connected. Imagine I take a coin and I toss it. Even when I toss, the person who is tossing doesn't know whether the outcome is head or a tail. I just toss it and I get something out here. Yes, I got a tail, but not a head. Next time, let me try once again. Now I want to get a head, and let's see if I get it. Yes, I did get it, a head. Once more I'll try. Now I want to get a tail. Let's see if I get a tail. Yeah, I got a tail, but surprisingly, let's see once more if I can get a head. No, this time I did not get a head. So this makes me understand that my outcome cannot be predicted when I toss it. So probability helps me in making some predictions on how much are the chances of getting a head when I toss the coin, or how much are the chances of getting a tail when I toss the coin, is what is probability. This session is about probability, which defines probability is a chance of happening or not happening an event. Happening, it may rain outside. Not happening, it may not rain outside, is how we make. So here I define probability is a chance of happening or not happening of an event. For example, tossing a coin is an event in which the probability of chance is of either getting a head or the probability or the chance of getting a head or a tail. You cannot have the chance of the coin landing exactly with the rim. There's no possibility. It can land either on head or on the tail, but it cannot land exactly on the rim. So there are only two possibilities happening. One is a head and one is a tail when a coin is tossed. So how much are the chances of getting a head and how much are the chances of getting a tail is what is the study of probability. We assume that when you toss a coin, there's 50% chances of getting a head and 50% chances of getting a tail, because both are said to have equal chances, and therefore in cricket matches we give equal justification to both the countries when a coin is tossed, so that there's no unfair justification. So for the outcome of which decides either a batting or a fielding option decided by the captain, the two teams or the two captains of the teams rely on tossing of a coin, assuming in mathematics that there are only 50-50 chances of getting fairly a head or a tail. So both of them are justified. No unfair part in the game. Is how probability convinces the cricket team and the cricket world. So how did we get this to be 50% chances? Or how did we get the tossing of a coin, the chances are exactly 50% of getting a head, and there are 50% chances exactly of getting a tail? How did we get to know about that 50%? Let's see that in brief, which makes us understand what actually probability is. But in general, probability is a chance. It's just a chance, but not a perfect prediction. It's a chance of happening or not happening of an event. Now let's see how mathematics have come to the assumption that when a coin is tossed, there are 50% chances of getting either a head or a tail. This is purely based on experimental approach. So understanding probability through experimental approach. Understanding probability through experimental approach. For example, let me take a coin and toss it 100 times. Say a coin is tossed times. Then secondly, it is tossed 200 times. And thirdly, it is tossed for 500 times. So in each of the coin, which is the same coin tossed for 100 times, 200 times and 500 times, I record the data each of the time. So here I take tossing number and I take the outcome. Say in my toss 1, I got a head. In toss 2, I got a tail. In toss 3, again I got a tail, or so on and so forth, is how I record up to 100 times, because there are 100 tosses in the first case. Similarly, I take the table of tossing 200 times and I record the data in the similar manner. And next, I toss the coin, the same coin again for 500 times, and then I record each of the tosses as given by case 1, case 2 and case 3. So here what we observe is, firstly, when I had 100 times when the coin is tossed, we get that, say for example, I calculate the tossing outcome. So here, for example, I calculate for each of the cases number of times a head comes by total number of times the coin is tossed. So for each of the three cases, case 1, case 2 and case 3, I'll find number of times a head comes as the outcome and total number of times the coin is tossed. So if I get, say, 40 heads in the first case and total number of coins is 100, then each of the times we see that there is some value which is obtained in either cases of 100 tosses, 200 tosses and 500 tosses. So interestingly, this experiment leads to a very interesting fact that as the number of tosses are increased, the value closes or tends to 0.5. Thus, 0.5 times 100 is 50%, which proves mathematically that there are 50% chances or equal chances, 50-50 chances of getting a head or a tail. That is, there is a 50-50 chance of getting a head or a tail is what we get. 50-50 chances of getting a head or a tail is how we conclude mathematically through this experimental approach, tossing 100 times, tossing 200 times, and tossing 500 times. If you toss 1000 times, then this value nears more to 0.5. So as the number of tosses are increased, the value tends more closer to 0.5, thus leading to understand that there are 50% chances of getting head or a tail, equal chances, and hence tossing of a coin is what through which the two captains decide on the batting or the fielding decision. Now that we have understood through experimental approach on how we get the equal chances or 50-50 chances of getting a head or a tail, let's try to introduce the concept of cumulative fraction. Cumulative fraction is defined to be number of times an event occurs by total number of times the experiment is conducted. So cumulative fraction is generally denoted by the formula number of times an event occurs by total number of times the experiment is conducted. For example, if a coin is tossed 200 times, so for example, I toss a coin 200 times and I get 40 times I get a head, that implies my cumulative fraction is nothing but number of times I get a head, which is 40, and total number of times I toss the coin, which is 200, which is 1/5. Therefore, chances or probability is 1/5 times 100, which is 20%. So here the chances are 1/5 of 100, which is 20% chances. So there are 20% chances of getting 40 heads when the coin is tossed 200 times. So here the chances of getting a head when the coin is tossed 200 times is said to be only 20% chances. Cumulative fraction equals number of times an event occurs by total number of times the experiment is conducted. Now that we have discussed about the chances of outcomes when a coin is tossed, now let's enter into understanding empirical probability. This session is about empirical probability. It is also given by the name experimental probability. So empirical or experimental probability. Here E is said to be an event. For event E, the event can be tossing a coin or rolling a die or any other playing a card, but for that event, the probability of event E is given by number of trials in which the event E has happened by total number of trials. Total number of trials is how we define the empirical probability. So here the empirical probability or experimental probability of an event E is said to be number of trials in which the event E has happened and by total number of trials. Let's take an example problem to understand this. So if I have find the empirical probability when a die is rolled 60 times in which a number 6 has obtained 15 times on its top surface. So here I have a question which relates to die or a dice. So we all know that a die is usually used with this shape. It has the numbers something like this. So this is the die. So in this case, a die is rolled 60 times. So here, rolling of a die is a trial. So the first thing I identify here is that the trial which I'm talking about in my formula is, for this example problem, rolling a die. So rolling a die is my trial. Now, it is rolled totally 60 times. So I have the total number of trials which is 60 because a die is on the whole rolled 60 times, in which the number of trials in which the event E has happened. Now here the event E is getting a number 6. Clearly in the question it says of getting a number 6. Therefore my event E is getting a number 6 on the top surface. As we can see, when I roll a die, I can get any number between 1, 2, 3, 4, 5 and 6. But to get a number 6 is the event on the top surface. So my event is getting a 6 on the top surface, and the experiment conducted has revealed that a number 6 has obtained 15 times on its top surface. Therefore, I have number of trials in which the event E has happened, that is number of times the die is rolled in which I got a number 6 on the top surface is 15. Therefore, my empirical probability is 15 by total number of trials, that is total number of times the die is rolled, as 60, which comes down. Is how I use the formula 15 over 60, which gives me 1 by 4. Therefore, my empirical probability of getting a 6 on the top surface is 1 by 4. The percentage chances would be 1/4 of 100, 4 2s, 4 5s, 25. That means there are 25% chances of getting a 6 on the top surface when a die is rolled 60 times. Empirical probability connected with rolling a die. Formula: number of trials in which event E has happened by total number of trials. Now that we have discussed about probability as a chance of happening and not happening with various different examples in its own experimental approach, now let's try to see some of the properties involved with probability. In the previous example, we have seen for a die rolled getting a 6 on the top surface, I got my probability value as 1 by 4, that is 25% chances. The value 1 by 4 gives me an understanding that probability always a fraction, or is it any natural number or a real number, is how we get various questions arising. So let's investigate the range of probability. The probability of an event E is always said to lie between 0 and 1, including 0 and 1. That is, probability of an event E. The event can be tossing a coin, rolling a die, playing cards, or playing cricket match, etc. That is, probability of an event E always lies between 0 and 1, inclusive, that is, including 0 and 1. But it cannot cross 1 on the right, cannot cross 0 on the left, which clearly makes me understand that, therefore, is always a fraction, except when it is at the endpoint 0 and 1. Except at 0 and 1, the probability is always a fraction, is how we come to the learning outcome. Probability always lies between 0 and 1 inclusive, and hence is always a fraction, except at 0 and 1. Range of probability for any event A.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.